Hello learners, welcome back to course MSD012 Ecosystem and Natural Resource of the program Postgraduate Diploma in Sustainability Science. Now, after having learned in the last session about the concept of resources and its renewability, how we use it, how we classify them depending upon the way we are using. Now it is time to look into how we are exploiting resources and how we have to manage it. So today we are going to talk on exploitation of resources management in this session, right? As we know in the previous session about the nature of resources, that these varies from society to society, and this variation of these resources from society to society is directly or indirectly related to the culture. We know that about traditional norms, the level of development, the nature of work in the society, and we exploit the natural resources since the beginning of human civilization. However, if you look into the situation in the beginning of human civilization, in that time resources were very abundant than the demand, because we have least number of population. So in that time no significant depletion occur, but with the increase of human population, with the advancement of human knowledge, that has considerable increase in consumption, especially during the last few centuries, that created a serious destruction scenario. So keeping all these things in our mind, the main objective of proper management of natural resources is to conserve our resources and utilize these natural resources in a sustainable manner. So today in this session, we'll look into this management of resources and how we have to look, or how we have to understand the concept of sustainable yields. We'll look into the problems of past resource management practices, which we have learned relations from that problems. Then the concept of maximum yield, that maximum sustainable yields and optimum sustainable yield. But how we know that resource crisis is happening, how to deal with and how to deal with environment degradation. When we talk about resource management and sustainable yield, we view the natural environment, we know that is the fact, as a resource. But it is a very narrow anthropocentric approach to nature. Sometimes, when we talk about resource management and this concept, it's thought to be because of human arrogance. And if you look from ethical viewpoint, it is questionable whether humans have a right to tamper with nature. And if so, how much it is justified? Then again, if you aside ethics, our assumption is, as a practical reality, to effectively manage nature is not shown in our human history. But these are some of the valid concerns, and now the need is for resource management. Human population is growing. In the same time, technology is also growing, and the pressures to exploit the environment is increasing. The only thing which is needed is changing the approach, where we have a concern for other organisms and integrity of natural system as a whole. So to achieve that, proper management will minimize environmental damage as well. Careful planning of different resources like water use can fulfill our needs without disturbing the integrity of different natural ecosystems. Furthermore, management can help undo what we did in the past, means that undo the past damage. Thus, resource management is not an attractive concept. If you look, in some ways it is preferably to the alternative, which is uncontrolled resource exploitation. So we need to, as I told you today, we need to look into the problem of past resource management practices, concept of maximum sustainable yield and optimum sustainable yield, and dealing resource crisis, environment and degradation, how to look from the lens of sustainability. When we talk about problem of past resource management, the society responds to a diminishing supply of resource in two ways. One is intensifying efforts to extract more of the resources. Second is reduce the need for the resources. We were very, frequent with the first response, and it was very common, intensifying efforts to extract more of the resources. And because of that, the usual result was a bubble pattern as depletion accelerated when supplies ran low. So the mining of, for example, the mining of lower grade high volume materials also led to pollution problem. Nevertheless, two influential concepts to justify this past intensification efforts, like net yield of non-renewable resources, maximum sustainable yield of renewable resources. So when you talk about again intensified extraction of non-renewable resources, here we again need to understand what is the net yield. When we talk about net yield, it holds that a resource can continue to be extracted as long as the resource used in extraction do not exceed the resource gain. That is, the unit cost of material is under the purchasing power of the market and no other option available. As the energy used in the extraction and the processing increases exponentially up to a certain point, and the amount of overburden and pollution also increases exponentially with depletion of high-grade deposit. For example, the miners switch over to low-grade deposit. So this greatly increased the available supplies because nearly all non-renewable resources are characterized by an inverse quality curve. So higher grade deposit of coal, oil, minerals and other resources are much rarer than lower grade deposit. So the net yield driven resource exploitation often encounters this bubble pattern of resource depletion. So the past pursuit of net yield has incurred great environmental cost by accelerating both depletion as well as pollution. This depletion accelerates because of growing demand, and that increasing lower grade ores must be mined and the more energy and other resources must be expanded to extract the ores. And the pollution accelerates because increasing amount of waste are produced in mining and processing lower grade ores. We know that mining may have to be curtailed due to the pollution generated by metal extraction rather than because the ores are actually depleted. When it comes into the concept of maximum sustainable yield and optimum sustainable yields, the maximum sustainable yields is the optimum way to exploit a potentially renewable resource to harvest as much as possible up to the point where the harvest rates equals renewal rate. Some of the example is say a person could withdraw as much as groundwater as needed up to the point where the withdrawal rate equaled the recharge rate from rainfall. This simple example. So taking less is desirable and taking more would lead to depletion. So maximum sustainable yield is particularly very useful for management of potentially renewable biological resources such as commercially important fishes, wildlife, different forest products, and etc. The basic principle of this maximum sustainable yield is that, for example, fishes, game and other population, they could be harvested up to the point where the population's ability to respond itself is impaired, which are governed by many factors like finding a mate, behavioral changes, the ability to counter natural forces, etc. On the other hand, some part of the population should be harvested because if population abundance becomes too high, further population growth is inhibited by overcrowding and competition. Thus, when you talk about maximum sustainable yields, this maximum sustainable yields aims at a balance between too much and too little harvesting to keep the population at some intermediate abundance, which ensure maximum growth rate of the population. So this maximum sustainable yield population is usually about 1/2 of the carrying capacity, right? It is widely practiced. We know that in regulating wildlife, forest and fishing, maximum sustainable yield has been heavily criticized by ecologists and others for both theoretical and practical reasons. An important theoretical shortcoming of maximum sustainable yield is it does not take large environmental fluctuation into account, which could reduce the population unpredictably. More important, some practical problems are the actual population size, calculation of the maximum sustainable yield point, calculation of the point where population faces natural competition, etc. Right? In many cases, such as marine fishes, animals in wilderness, etc., they are just calculating the population size. Calculating such kind of population size is very difficult. Some statistical modeling can do some estimation, but still the decline in commercial fishing in many areas indicate that humans are not harvesting far more than the maximum sustainable yield. So a variation on the maximum sustainable yield concept known as another is that optimum sustainable yields. This optimum sustainable yields takes into account many factors such as how the harvest will affect other species and the functioning of the ecosystem, how it will affect other human uses of the ecosystem, like recreation and such other benefit cost questions. So these are some of the concepts we have to understand when we are looking at the natural resources, right, from the lens of sustainability. Coming to how to deal with resource crisis and environmental degradation. It is well recognized that less resource use can ensure reduced environmental and health costs and long-term economic benefit. So looking into that, there are 3 basic options that resource management can apply to minimize resource use. One is preservation, second is conservation, and third is restoration. When you talk about preservation, it refers to non-use. For example, a preserved national park or wilderness area, it is an ecosystem that is set aside, and in theory, if we look into, we set aside and protected its pristine natural state. Right? That means we are not using that direct use. Then when we talk about conservation, that is input reduction. It is attempt to minimize the use of natural resources. We can minimize the use through efficiency improvement, recycling or reuse, substitution of other resources, increasing cost, use of services that is meant for masses than individual arrangement, and most important is getting satisfied with the minimum that is possible. So finally, when we talk about restoration, restoration seeks to return a degraded resources to its original states. For example, restoration of mine areas, restoration of lakes, all the degraded lakes. So here, preservation and conservation are more cost effective than restoration, because restoration are extremely expensive. But when we apply this principle of restoration at a landscape level, it is most effective. So we need to ensure restoration. Example of an acidified lake affected by acid mine drainage can only be effective by restoring the whole landscape to restrict acid runoff than the lake individually. So similarly, reintroducing wolves for any of the species into a small forest is unlikely to be successful unless the natural ecosystem of the entire region is prepared to support them. Right. Then coming to exploitation of resources and issues of sustainability. One of the most sensitive questions posed in the context of world natural resources, how long and under what condition can human life continue on Earth? The stock of in situ resources are finite, especially the mineral foils, and the rate of consumption of these stocks are accelerating That is why the exponential reserves are much shorter than static reserve. So under the condition of reducing stock, there will be growing dependence on increasingly low quality reserves of natural resources. Poor quality, more will be the consumption of resources. Means the process like energy, labor, etc. Then when the consumption of resources is more will be the process of waste, overburden of mining, and other effect like pollution, more pollution. So at a point of time, the energy requirement may become prohibitive and the pollution pressure on environment components may become too intense to bear. Again, under such condition, the place of major consumption differing from the location of reserve will have strong geopolitical implications leading to conflicts. So the over dependency on non-renewable resources that will create a great disturbance in the biosphere, or it has already created. One major example is what happened with the increase of greenhouse gases that induced to global climate change. So the awareness about this fact is inducing a shift to increase dependency on renewable and potentially renewable resources. But while doing so, the raw material requirement and pollution generated that need to be taken into account, particularly while dealing with potentially renewable resources, as their renewability is conditioned to exploitation environment condition. So in determining how resource will be managed over time, market processes have a great role to play, and so they have the duty to act in a socially responsible way. The wisdom of past pattern of resource utilization could be nationally guide for present approaches. More importantly, the role and importance of natural resources and environmental services that need not to be forgotten. They may not be freely available for the future generation, right? So it should be remembered that the environment is not a waste pool, and the carrying capacities of environmental system are limited, right? So we need to understand resource right and resource flow. Like human beings, all other organisms, they also have the right to live. They are also an integral part of nature. One must understand that every living and non-living entity on this globe is directly or indirectly contributing to the resource pool. So in other words, we can say that the world in its totality is a resource for every living organism. This means that the integrity of the whole biosphere is essential for maintaining the resource pool. The integrity of biosphere is essential for sustenance of every individual in narrow scale and for the existence of life in a broader scale. So from ethical point of view, the resource requirement of other organisms for sustenance of life in this earth cannot be denied. So the essential elements like air, water, food, then all that they come from the ecosystem of life, all this also their rights. Nobody is entitled to create any kind of disturbance in getting their life supporting requirements, right? But the irony is that we the Homo sapiens, with our selfish motive and a disregard for this integrity, when you talk about integrity, it is not only about the other organism, it's including us, our biospheric resource pool, are creating disturbance in the fine balance. If the resource right of other life forms are diluted or denied, the ultimate result of collapse of the system will be borne by the whole biosphere. So that's why at this point of time, one should not forget about the right of the lives that are yet to take part on this earth. That's why we have to understand the real meaning of what is sustainability, what is sustainable development. Thus, the totality of living, non-living, or bio or non-biodiversity of the globe contributes to our resource pool. The biological resource pool is dependent on the non-biological resource pools for the sustenance both in natural ecosystem as well as human engineered biosystem. Out of these two, the main engineered biosystem are highly dependent particularly on non-renewable resources like mineral elements and fossil fuel. So these systems are again not standalone system. They are equally dependent on a biological diversity, which is responsible for pollination, like bee insect, for nutrition, for disease resistance and stress tolerance, then for high productivity control the parasite base, etc., for productivity and existence of the nature. Therefore, we need to ensure the sustainability in flow of resources. From such system, one need to sustain the stock of non-renewable resources as well as the potential and that the potentially renewable resources. Since we know that unlike the perpetual and renewable resources, the non-renewable resources are limited and the renewability of potential renewable resources is conditioned to its rate of exploitation, we have to adopt a multi-pronged approach. This multi-pronged approach would be first reduction of the demand, second shifting the dependence of non-renewable resources to potential renewable resources, third adopting a strategy which minimizes the utilization of perpetual and renewable resources. If we summarize what we have discussed today is, first I would like we have to understand from the lens of sustainability is there are three basic options that resource management can apply to minimize resource use: preservation, conservation, restoration. So we look into how we have to manage resources and what are the different concepts related to resource management, like sustainable yield, maximum sustainable yield, optimum sustainable yield, and we talk about how to deal with resource crisis, environment sustainability, environmental degradation. So we also have a quick look into exploitation of resources and issues of sustainability. With this, thank you very much for this session. Thank you.